If you want to think about it from your, I just started recording. I forgot to record before, but so at least we'll pick up some of it. If you want to think about it from your perspective, you can think about it as all these different subjects we're making you take. You're taking a networking course, you're taking some programming classes, you're taking a database class, all these different things, all these different subjects, okay? Even though they are different subjects, they all are connecting to computer science in the same way. And they all share huge overlaps of information. So it all just depends on which lens we're looking through. If we're looking through the lens of the networking class and thinking about how does the underlying technology work, it might look one way to us. But if we're looking at it from a database class, we still care about the same stuff. It just might, the things we care about related to it might be a little bit different. Okay, but these things all have overlap, and that's especially, I think, true when we think about some of our newfangled things like artificial intelligence and things like that. These aren't like brand new inventions that are creating new technologies. It's effectively more new, interesting ways of working with our older technologies. You know, if we look over the last 20 years, the technologies that we have hardware-wise have not drastically changed in terms of goal. Maybe their function has gotten faster over the last 20 years. Processors are certainly faster today than they were 20 years ago. But here's an interesting question. Are processors faster today than they were 5 years ago? What do you think? If you buy a laptop or a desktop today, is the laptop is probably maybe a good example. If you buy a laptop today, is the processor inside of that, the CPU, is that faster than a processor would have been 5 years ago?
No.
No.
Why not?
Maybe the M1 Max or the ARM structured.
Okay, well, so if we start thinking about mobile processors today, they're using a different chipset called ARM. Yeah, but I'm just using that term faster fairly generically here, because it really, that kind of goes back to our example of how do we measure our internet connections, right? What does fast mean? But let's think about it very generically here. So you said that if you buy a laptop today, it's not necessarily faster than a laptop from 5 years ago, right? The processor.
Yes.
If we're just measuring the processor. Well, shouldn't it be? I mean, a lot has happened in the last 5 years with technology, hasn't it? So if you were to describe in the last 5 years, what's happened with technology, what have been the biggest breakthroughs in technology, what would you say?
Maybe storage speeds, read and write speeds has increased. More and more devices are using SSDs now.
Yep, so that's definitely a true statement. So if we think about our hard drives in our computers, and 5 years ago SSDs existed, but you're absolutely right. Today it would be difficult to buy a computer that doesn't come with a solid state drive.
Multitasking.
Yeah, where 5 years ago we were paying a premium for it. Multitasking, well, maybe I think that's along the lines of maybe what I'm asking. So what you're talking about is maybe the number of cores, right? So when we think about a processor, where processors are, they're no longer single core processors. Now our processors can do more than one thing at once. So even though they aren't getting any more faster on they aren't getting any faster on a per core basis, they're getting a lot faster in terms of the number of cores we get onto the chip, right? 5 years ago, probably we would buy like a quad core, where today having 18 or 16 or there's 48 core processors. Now more cores doesn't necessarily mean faster. That's not what we talk about in the 548 class that you'll have with me as well. More cores doesn't mean faster, but it does mean more capable. If you were to come up with ways of taking advantage of those extra cores, it could be more capable, but that's not necessarily different than what we're talking about with our network hardware in here, where we say, like, look, you might have the latest, greatest, coolest router capable of, moving 100 gigabits per second across it. But if you don't have that much data, you're not using that fire hose to its full capability. Does that mean you shouldn't have bought the fire hose? No, it just means that you're going to grow into it. That fire hose is going to last you for the next 10 years or so as your data ability becomes larger and larger and larger. Okay, so we see those same patterns happening. All right, so back to our example of the laptops. If you buy a laptop today versus a laptop 5 years ago, what would you say is a common difference that you'll notice in laptops today versus 5 years ago?
Like today's laptops are using two processors, like graphical processor and another processor for browsing the things, and the other process.
Okay, yeah, I think there's some truth to that. What about physically?
Yeah, they have been more smaller and smaller. They are getting smaller and smaller.
Yeah, smaller and smaller without sacrificing battery life, right?
Battery life.
Yep.
Yes.
So,
Right.
you know, you can buy these very powerful computers today, relatively speaking, that are like infinitely thin. You know, like I mentioned earlier, at my house, I have a MacBook Air. Right now I'm on a 16-inch MacBook Pro. Now, for those of you who know about computer hardware, I'll show you the specs on my current computer. So there's the specs on the computer that I'm sitting on right now. So what I'm on right now is a beast, right? And this is a laptop. So I have a laptop computer that has 16 logical Core i9 processors and 64 gigabytes of RAM.
Cool.
That's ridiculous, right? That's tons
Yeah.
and tons and tons and tons and tons of power. Well, why do I need that much power? Is it just because is it because like when I go to the gym, I want to flex? I want people to see me lifting tons of weight, even though there's no real use in real life to be able to lift up a car.
You play games, I guess. There is a Epic launcher down there.
Oh, this isn't that great of a graphics card though. This is
Yeah.
this is good for mobile graphics, but you know, at my house I have a 3090, NVIDIA GTX 3090.
Wow.
So yeah, that's for my VR stuff, right?
Mm.
Yeah, but this is my mobile thing. This is just this is my toy I play with. All right. But most people would look at this like if my my dad, let's say, if he's not a computer scientist, he's a retired dentist. Does my dad need a computer like this?
Oh,
No, most
No.
probably.
No, I mean, because he's not going to come anywhere near to using the resources of this guy, right?
Right.
This is why I use this computer. I
run
don't,
virtual OS.
I can run all of these operating systems at the same time through parallels and have plenty of system resources to support all of them. Does that make sense?
Yes.
So as a professional developer who's also a teacher, who's also using all these different platforms on a given day, potentially, I have a single device that's flexible enough to allow me to do all those things at once. Okay. It's compatible with how I use computers. Okay. But this is, I mean, this is just a waste of money if we're talking about buying a computer for my dad, right? If I'm buying a computer for my dad, I mean, sure, maybe this 2.4 gigahertz processor is good, but I'm probably going to get him an i7 instead of an i9. But even if we say this is okay, he wants the highest end thing, that's fine. But he doesn't need probably more than 16 gigabytes of RAM. Maybe you throw 32 in there, especially if you're buying a Mac, because when you buy it, you pretty much need to max it out because that's what you're going to have forever. You can't upgrade them, right? But a lot of the stuff that I bought with this, he's not going to need. He's never going to use, yet he's going to have the same performance that I have. Now, a majority of the time. At my house, I have a MacBook Air that I take with me to coffee shops and stuff like that. Sometimes I bring this, but I generally just grab my MacBook Air and run out of the house. So my MacBook Air has a 13.3-inch screen. Yes, it's a smaller screen than this, but not by a ridiculous, thing. If I was working for multiple hours on this computer, I'd prefer to be on this screen. But for doing email and stuff like that at a coffee shop, or putting together slides for a class or something, a MacBook Air is perfectly acceptable. What are the advantages of a MacBook Air over this computer? So those of you who know what a
Access
MacBook Air
memory.
is.
MacBook Air has
Easily carryable.
Yeah, super light, right? The MacBook Air, even though this computer, I can say this computer's, very portable, it's easy to carry around and stuff like that. This guy weighs a lot more than that MacBook Air weighs. That MacBook Air is like the size of an iPad, right? And it's thinner, it's actually thinner than my iPad is. So, MacBook Airs are very portable. You mentioned a few minutes ago about new processors. So the MacBook Air is running on Apple's latest their own silicon, their own processors. It's M1 processor. Relatively soon, I'll probably grab another Mac that's running the M1 Max once they're actually shipping those. But I'm not necessarily sold on the M1 Max yet for virtualization. I need to do some testing to see if that M1 Max is going to let me do all this stuff at the same capacity as my current computer can, right? But now, here's where you start seeing differences. If I'm on a 1-hour Zoom call with this computer, I'm on a 1-hour Zoom video call on this computer, and I'm running off battery life, and I started that call off at 100% battery life. What do you think at the end of that hour? What do you think my battery percentage is on this computer after 1 hour on Zoom?
Might be 40.
95, 96%.
On this computer?
If you are just using Zoom, right? Nothing else.
Sure.
I think it was 56 or 60.
It's probably going to be about 65, 70%. Yeah, it's going to drop quite a bit because it's using my computer, it's using the monitor. Now, I mean, what are some things you can do? You can turn down the brightness a whole bunch and stuff like that. But generally speaking, it's going to take more electricity to drive this monitor. It's going to take, to run those video signals and run the network stuff, the software that's handling all those people that are on the Zoom call, that takes resources, all that stuff. So I'm going to be at 70%. If I did that same Zoom call on my MacBook Air, what do you think my battery percentage is going to be at the end of an hour?
40, 50,
99%.
99.
Wow, it's good.
Wow, that's
So-
so good.
If you were to ask me, what's the killer application of the M1 processor? Now, is the M1 processor as high performance as my processing power on this computer? No, it's not. But is it good enough for a huge percentage of things? Like 99% of the stuff that I might do on a daily basis, an M1 processor is good enough for. Now,
Yes, for office.
yeah. Now, if we jump over and we start talking about Apple's newer processors like the M1 Max, and we'll talk about these things in a lot more detail when we get into the 548 class. But if we go over to like the M1 Max processor, well, now we're starting to talk about, hey, that might be a legitimate competitor to an i9, at least for certain applications. Okay. But if you were to ask me, what's the greatest benefit of the M1 processor, is I would say it's plenty fast, but its power consumption is tons less than the power consumption of an Intel processor. It's not even close. The M1 the M1 processor uses very little energy, to the point that it's almost scary. So I asked you over the last 5 years, what has changed in our computers? Well, fine. I mean, every single year when Intel comes out with a new processor, what do they say? It's like up to 200% faster than last year's processor. That's going to be for some very, very, very specific little thing that was just newly added to this new processor that's only going to be used in very specific applications, once in a blue moon, that kind of stuff. But they can legally say, yes, it's faster because we've added this new ability. But for general purpose stuff, the things that you're doing on a daily basis, it's really not going to be faster. It's going to be more memory efficient. It's going to be more power efficient. It's going to probably run cooler, so it's not going to be as hot. It's probably going to be smaller in terms of number of transistors on the processor, which then allows them to add more cores, things like that. So we're in the age right now of miniaturization, right? Now we're getting to the point where we can keep making things smaller and smaller and smaller. And if you think about your cell phones today, we've your smartphones, what has happened? We've reversed it, right? You know, now our phones keep getting thinner and thinner while still having big battery life and still having bright screens, and you know, they're basically computers in our pocket now. But now we're starting to see a reverse trend of having bigger screens, you know, because we kept shrinking down the screen once they got to a point where, you know, we kept making them, because a big screen takes up a lot of battery life. So as our battery technology got better, we're able to make the screens larger while still keeping the number of hours the phone will stay alive at about the same. So these are the things that we've seen happen with technology more recently. All right, so when we talk about our network type hardware, similar stuff has happened. You know, we have noticed speed differences and things like that in terms of maximum capability, but we're really dealing with the same kind of hardware as we had 20 years ago, just like our processors today roughly do the same kind of crap they did 20 years ago. They just can do it, you know, more, you know, faster, you know, in higher levels of being parallel. You know, you have multiple cores and stuff, things like that. All right, so in network computing, we have this idea of a multiplexer and a demultiplexer. This allows us to take multiple channels, squeeze it down into one channel. That's a multiplexer. And a demultiplexer undoes that. Okay, so that's a piece of equipment that exists. Cable TV is going to kind of take advantage of something that does some level of multiplexing, where you know, they maybe have 100 channels, and those 100 channels need to travel over that single coaxial cable network. And so those 100 channels are going to go through a multiplexer of some type, and they're going to get encoded in some way so that they can travel over that network as a single entity. That box that's on top of your TV for cable TV, for example, that's going to act as some kind of demultiplexer. It's going to receive that signal, and it's going to be able to pull out those individual 100 channels so it can work with them. Okay. Well, last time we talked about the size of if we want to stream Netflix. So a very common application people use on networks today is data streaming. So we watched, like this whole weekend, I was binge watching TV shows on HBO Max, and then on Amazon Prime, which once I finished one series. Okay, so the amount of data I must have used at my house this last weekend must have been ridiculous. But we talked about last time where, you know, doesn't matter how fast your internet connection is, even our very, very, very fastest consumer internet connection today really can't keep up with full HD raw video streaming. It can almost do it. I think we saw it can almost do it today. I think it was like 144 megabytes per second is what was required to do full normal HD 1080p video, where our fastest internet, gigabit internet, could do 128 megabytes per second. So it can almost keep up with that, but now we demand 4K. You know, both TV series I was watching were in 4K. Well, we're nowhere near keeping up with that with our internet connections. So we're going to need that data to exist in another format, okay? Because our transmission speeds, the speed limit on the highways that this data is flowing over, the medium that data is flowing over, has a capacity. It can hold so much data, and it can only travel along that cable at such a fast rate before it falls apart, before it has a problem, whether it's heat or signal degradation, whatever it is. All right, so these are all things that play into this problem. So that's where we augment the network capabilities. What lives between my TV and Netflix is a computer network. You know, my access point to that network is my cable modem at my house. You know, Netflix is going to have multiple servers in multiple places around the world, and they're plugged into the internet through, you know, some sort of, you know, data pathways that they've purchased, not consumer internet. They're patched in through commercial networks. You know, they are legitimate, powerful nodes that live on the internet. So, but any way you cut it, from my perspective, I am feeding off the internet through my cable modem, and Netflix is pushing data over the internet that my cable modem can now get. But I am at the mercy of the total amount of data that the internet can handle at one time. Now, the internet's a collection of a whole bunch of different nodes, right? So to say what's the speed of the internet is not really a fair question to ask, because it depends on where you're measuring it. You know, but if you said, well, what is the maximum speed of the internet, you're going to have the biggest companies that have the most money for the most bandwidth. That's going to be your maximum speed, and then you're going to have the average speed, and yada yada yada. But regardless, there's a whole bunch of stops between my house and Netflix. So you can almost think about this like airlines, right? You know, if I'm flying to, you know, I was just recently looking at airline tickets to fly from Milwaukee to Seattle, Washington, which is on the West Coast of the United States. Well, some of the flights go through Atlanta. Well, that seems weird. Why would I fly to the East Coast of the United States to get to the West Coast of the United States? Well, it's because that's the direction the airplanes fly, right? You know, so the idea is that even though it feels like it's not a direct flight, you know, it's not the least, you know, shouldn't I fly from Milwaukee directly to Seattle? That doesn't seem like it'd be that long of a flight, maybe a 4-hour flight, something like that. Why am I flying 2.5 hours to Atlanta just to fly 6 hours back to Seattle? That seems ridiculous. All right. So, you know, the total flight time, let's say, is 8.5 hours, something like that. Well, how long would it take me to drive to Seattle from Wisconsin? A lot more than 8 hours. You know, probably something in that, you know, 30 hour range, give or take. Maybe it's 20 hours, 25 hours. Okay, a lot more time, because the network between here, that my maximum speed between here and Seattle by car is limited by the maximum speed of my car, and then further limited by the speed that the roads allow me to travel, right? Whereas with air travel, my speed is limited by the maximum speed of the airplane, and then limited by the airlines algorithms for how to be most fuel efficient to make the most money for the companies, and things like that during those during the flights. So the airlines have decided that it's in terms of the number of people flying, it's better for them to fly from Milwaukee to Atlanta to make a plane available to the people on the East Coast, and then have me switch planes and then catch a flight from Atlanta to Seattle to make another plane available on the West Coast, but carrying a bunch of people from the East Coast to the West Coast. You know, so even though to a human being this doesn't seem like a very direct path, I'm still saving a bunch of time, and the airlines are getting their airplanes where they need to be with the people that demand to go to those places. You know, on a given day, probably far more people are flying from the East Coast to Seattle than are flying from Milwaukee to Seattle. So you're better off gathering all those people together in a centralized place like Atlanta, and then taking them all to Seattle so you can fly with a full flight. So these are some real life examples of things that exist in our that exist in our network world. Similar, you know, similar decisions get made. You know, also some roads don't go to certain places, so we need to travel over the network in different ways in order to get there. All right, so we are at the mercy of how the network, how the internet is connected, and things like that. And ultimately, if we have 100 channels coming over our cable, and we want those channels to all be high definition, well, now we need, last time we were talking about, well, if for high definition we need 144 megabytes per second, and now we have 100 channels. So that's 1,000, or that's 14,400 megabytes per second divided by 1,024. That is 14 gigabytes per second of data that needs to move in real time across a coaxial cable. Now, a coaxial cable can't move 14 gigabytes per second, even if the hardware can send and receive it, which it also can't. Okay, it just can't move that much data. Well, so what do we need to do? Well, now you need to do something with the data. If you want to have high definition channels, and now we want 4K channels, we want even higher definition channels. If we want to have that, and we want to have a bunch of channels, we need to start looking at things that we can do to the data to make it pretend to be smaller during the transfer. And then we can re-inflate it on the end using our individual computing power. So that's where data compression comes in. All right. So a question we might ask, do we need 1 gigabit per second internet for HD Netflix? No. Most of you in here, you watch Netflix, and you probably are watching HD channels on there. And I'm guessing probably none of you have gigabit per second internet. Okay, or at the very least, a very small percentage of you will have that. Most of you have 100 or 200 megabit per second internet or worse. All right, that's just, for this demographic. You're going to have the cheaper side of internet to make it affordable. Well, but you still want high definition Netflix, and you've noticed that you can get it. So you don't need 1 gigabit per second internet in order to get that high definition video. All you need is fast enough internet, because you're reliant on the magic that is happening over the internet. So let's just do a search. How fast does my internet be for HD Netflix? Five megabits per second to watch Netflix in HD. 5 megabits. Yet we looked last time and we saw that Spectrum, their cheap internet these days is 200 megabits per second. What if I change this to 4K? Netflix. 4K Netflix says 25 megabits per second. So 25 megabits per second will allow us to have 4K video. Okay, here was the comparison right here. HD versus 4K. Realistically, this is 720p. So if I want 1080p, it's probably gonna be a little bit more than this, but still far less than even our cheapest internet is today. And we can do it. All right. So with that in mind, so let's actually put that in here. 5 megabits per second for HD, 25 megabits per second for 4K. That's the speed that we actually need for this. So we can say, so 200 megabit per second internet is plenty. So why buy fast internet? Why should you get any faster internet than the cheapest you can buy?
For faster access to the required data, or to downloading the files and to uploading the files.
Well, but are you really doing that? I mean, let's think about how people actually use their internet at home. I mean, if watching a 4K movie only takes 25 megabits per second, isn't that likely going to be the biggest user of your bandwidth at your house? I mean, that's going to be way more data than you're using to do email or web browsing or something like that, right?
Yes,
So
pages will load.
unless you're doing something very specific, you're running a server out of your house or something like that, you're a high-end user. Generally speaking, most families don't need that fast of internet. But why would they buy faster internet? For instance, why does Spectrum sell as their baseline internet 200 megabits per second, when we just saw that you actually don't need more than 25 megabits per second to watch 4K?
For big data,
Well, okay, what big data?
like huge files and doing using complex softwares.
Well, but that big data, like let's say it's like downloading an update to Windows, something like that. So if you're downloading an update to Windows or an update to a video game or something like that, let's say it's a 20 gigabyte file, you just leave it downloading overnight. That's not considered real-time use of your internet, right? So you don't actually need it to be tons faster. So why does Spectrum sell their cheapest internet as 200 megabits per second? And we can say that that's good for most families. But why don't they sell a 50 megabit per second? If 25 megabits per second is enough for 4K Netflix, why do they sell 200?
Latency.
The 200 megabits per second doesn't necessarily mean lower latency. You could have crappy latency on a 200 megabit per second connection and really good latency on a 24 megabit per second connection from AT&T. And next time we'll talk about modems and really this is DSL versus cable modem. So yeah, the speed of the internet, the 200 megabits per second they're selling, that doesn't tell us really anything about latency. How many of you have roommates? Most of you? Most of you live with some other students, or you are staying with family members, and you might have 2, 3, 4, 5, 6 people living in the same place, right?
Yes, exactly.
Right. And are all those people, or are several of those people internet users?
On the same medium, right?
Yeah. So well, but not necessarily. Is it possible that you're watching Netflix in one room and somebody else is watching Netflix in another room?
Yep.
That's something
it's possible.
Yeah, that's something that's possible. Heck, it's possible for like 3 or 4 or 5 people to be watching that. I think Netflix max is at 4. I think it's 2 screens is the default Netflix. And if you get Netflix 4K, you get up to 4 screens. Okay. That's to protect people from sharing their Netflix password with their 4 million friends.
Yes.
Right. So even if you're paying for the maximum speed Netflix, the maximum definition Netflix, you could potentially have 4 people in your apartment all watching Netflix at the same time. So that's going to take up 100 megabits of your connection, right? For that to happen. Yeah,
Yes.
you might have somebody else who's also, they have their laptop on, they want to be able to receive email and things like that. Maybe they're doing some chat sessions, some different uses of the network. So other extraneous network stuff. All right. So why buy fast internet? For a single user, maybe 50 megabits per second is plenty. If you have multiple people using the same connection, you need to multiply that by the number of people. Maybe a family of 4 needs 200 megabits per second to be comfortable. You could probably get away with less than that, but at my number of 50 megabits per second, that's basically saying everybody can watch 4K Netflix and do some other stuff. They can,
Yes.
doing stuff on their phone and crap like that with some data
Streaming.
there.
Yes.
200 megabits per second is what you need for a family of 4. 400 is if you're going to be doing extra stuff for a family of 4, or you have more people sharing it, yada yada yada. Then you have your power users that are going to be doing a bunch of different stuff on their network, and because even though there might only be 3 people living there, you might each have 5 different network connected devices, and each of those network connected devices is taking up some amount of your bandwidth. All right, so these are all things that are using our data, and that starts adding up. All right, that makes some sense.
It's look like demultiplexing.
Well, I guess, but I would say this is solving a different problem than the multiplexing and demultiplexing. You are, well, you know what? It's not. I think you're right. Let me actually write that down, because that's, so is this like multiplexing / demultiplexing? I would say the answer is yes. So most of you in your house, you have your internet connection coming into a router. Okay, so most of you probably have a Wi-Fi router in your house, right? So a Wi-Fi router creates a Wi-Fi hotspot in your house, and also allows you to have some wired devices plugged into it if you wanted. So realistically, most of us operate off of Wi-Fi for most of our devices these days, but maybe you have your computer, if it's near your modem, plugged in through wire. Maybe you have your Xbox, your video game system plugged in wired. But most of what you're doing is through the wireless connection. Doesn't really matter. That comes back to our slide here about the different mediums, right? So we have in your house, you have some stuff coming over wireless. We have some stuff coming over Ethernet, but they're all going through that same Wi-Fi router. And what does the Wi-Fi router do? Wi-Fi router takes requests from all the network connected devices in your house and makes those requests on their behalf on the internet, gets the response and routes that response to the correct device that requested it. Okay. So I would say, does this work like multiplexing and demultiplexing? I would say,
Demultiplex.
well, No, I would say no. And the reason is it's not necessarily sending 10 signals at once over the network. What it's doing is
Yes.
it's sending individual requests. So this is more of having like a first come, first serve person who will make requests on your behalf. So at any one point in time, there's only going to be 1 or 2 or 3 requests happening over the network at once, depending on the number of cores and the small processor inside there. So we can say not exactly like multiplexing, since the router is just responding to clients on an as needed basis rather than bounding connections together and sending them at once. So it's fair to ask the question, is it similar to multiplexing? I think the answer is yes, it's similar. We're doing a very similar thing. Rather than sending 10 signals at once over a single cable, we actually have this little computer or this Wi-Fi router that sits there, and it just deals with us on demand. When our computer asks for something, it goes and gets that answer for us. It doesn't wait for 9 other computers that need data before it bunches it up and sends it over the network. So it's solving a little bit of a different problem, but in a certain way, it's getting all that stuff at once. Most Wi-Fi routers get the real IP address from the cable modem and then hand out fake addresses to the internal computers. And this is called a NAT. So at some point in here, we will talk about NATs. This is network address translation. Give me 1 second here. You're yeah, those you're
I know what it is.
okay.
这个在一个插播。
All right.
那个所有的考虑。
So yeah, so network address translation, we'll talk about that later for how that works, yada yada yada. Okay, so what we're going to do is we're going to come back next time, and we're going to talk more about kind of where our internet started in terms of dial-up stuff versus DSL versus cable. And we'll talk about that. That's in that same conversation. And then we'll talk some about this network address translation and how does that work. What I'll do is here in a little bit, I'll send out, I mean, most of you have access to it now on Blackboard, but I'll send out another email to people who don't have access to Blackboard. So like I said, if you're one of those people, if you don't have access to Blackboard, send me an email at today, and I will reply with the assignment for this week from Blackboard.
Sir, one question, sir. What about previous assignments, sir? Because this is
Yeah,
first week.
if you need previous assignments, ask me for it. Tell me what you've done so far. If this is your first class, tell me
Yes,
that,
sir.
and I'll give you everything you need. But get that stuff into me as soon as possible. This first week might kind of suck for you, but you're already, this is our 3rd week of class, so we need to get you caught up quick. Sound good?
So, like previous assignment, can I do later? Now on, can I do for this 3rd assignment?
I would say you probably want to do the first assignment first, and you want to do them in order because
Okay.
they build on each other.
Right. Okay, so thank you.
Okay? But
Sure.
make sure you tell me in that email what you need out
Okay.
of the assignments. If you've already done assignment 1 and 2 and you just need 3, let me know. But if you haven't done anything, let me know that too. So I can send you all the assignments because we want to get everybody caught up as soon as possible. And we also want to get you registered for the class as soon as possible. But I realize that you're waiting on your F00 number and stuff like that.
Yeah.
Right, exactly, sir. Yes. We are
And I
waiting
get
for
it.
that.
That's fine. We'll burn that bridge when we have to. We'll get you into the class. But for right now, I want to make sure you can keep up with the stuff. Sound good?
Okay, sounds. Thank
So-
you, sir. Thank you.
So this is for the,
Yep. What's up?
yeah, like I'm almost done with my 2 assignments, but last week I missed out the classes due to some flight delays and I was on my journey to US. So like, can I send those assignments to you or else shall I directly submit to the Blackboard once I get the access? Like most probably I'll be, as per Robin words, I'll be getting the access today.
If you have access today, just submit them to Blackboard. If you want, email them to me so I have them, and then also submit them to Blackboard when you finally have access.
Yeah, like I'll wait for the end of the day. Like if I get the access, I will
That's
do
fine.
directly. Yeah, fine. Thank you.
Okay. All right. So we'll reconvene on Wednesday at 8 a.m. So same time, same station, and we'll keep going.
Thank
All right. You guys have a good one.
Good. Thank you, sir. Thanks a lot.
Thank you.
Right.
sir.
Bye-bye.
Thank you.